So there was no instructional video today, and I'm trusting that you've already answered the practice questions before watching the video. If you have not, please stop the video and do so. Alright, getting ready for a test next week, so let's go through what you needed to do on these. You need to define the mean absolute value deviation. Remember, that's the MAD. It's been a while since we've done that. In order to do that, you do need the mean. Yes, you can absolutely put it in the calculator to get the mean, or you can add it up and see that it's 880 divided by 5 is 176. Now you take the 176 and subtract it from each of these values to get the deviations. So from 157, it was 19. From 174, it's only a 2. From 176, well, it's none. 180 is 4 away, and 193 is 17 away. Add all those up and divide by 5 because there's 5 values. 42 divided by 5 gives you an 8.4 for your MAD, for your mean absolute deviation. Number 2, on a recent Latin quiz, 2 people scored 100. We are going to look for the standard deviation, so I think as I'm reading this question, I'm going to go ahead and put them into the calculator. So I've gone my list and I've cleared it out. Now I'm ready to enter in. On the Latin quiz, 2 people scored 100, so let me get the 100 in twice. 3 people scored 90. 5 people scored 80. And 1 person scored a 70. Now I'm looking for the standard deviation. All my values are there, so I just am going to do stat, calculate, 1 variable statistics. My standard deviation is right here. It's about 8.9. Question 3, you want the variance. Remember, variance, it's standard deviation squared. So again, I think the easiest thing to do is to go to my list, put in the values, now, if you're one of the few people that do not have a graphing calculator and are not using the emulator, remember, you can do this by hand. You just find the MAD, you square them, you divide by how many you have, and then you square root them at the end. Since I have it in the calculator right there, my standard deviation is about 5.97, which rounds it up to a 6. Now the variance is 6 squared, which is 36. Okay, number 4, it wants you to find the difference in the MADs, so you have to do it twice. Trusting that you can find the average on these. This one has an average of 16, and this one has an average of 25. I don't think I would put these in the list. It's pretty easy just to add them up and divide by how many you have. Now, figure out how far away they are from the average. The 9 is 7 away. The 12 is 4 away. 16 is 0 away. 19 is 3 away. And 24 from 16 is 8 away. Divided by the 5 values is a MAD of 4.4. For set B, 2 is 23 away from 25. 11 is 14 away. 29 is 4 away. 35 is 10 away. And 48 minus the 25 is 23 away. 5 values as well. Add them up, divide by how many you have, and it's 14.8. Now it wants the difference between those. That is 10.4. We want to figure out what Tom's score is. We don't know. Excuse me, not Tom. This is Katie, number 5. Katie is 62 inches tall. The mean height is 60. The standard deviation is 1.5. 62 minus 60 is 2. Divided by 1.5 gives a z-score of 1.3. Now number 6 is the one that has Tom. So we don't know Tom's score, but we know the average is 360 and the standard deviation is 15, giving a negative 0.60 z-score. So I'm going to take Tom minus 360, multiplying by 15. I get a negative 9. Negative 9. Add 360, and signs are different. Subtract and take the sign of the larger, 351. All right, number 7. What is this one? Before I read all the problem, I'm just going to go right down to the end. It says, how many have a z-score? So you're looking for the z-score. And you want it to be less than, that's going to be an inequality. So my value minus the average divided by the standard deviation has to be less than negative 0.4. Okay, I'm going to multiply 3.8 by the negative 0.4. You get 1.52. Add the 27. That was negative. So 27 minus 1.52, sign of the larger, is my scores have to be less than 25.48. So looking at the group, all the ones that are less than 25.48 are right here. Now the question says how many of those? There's 7 of them. Okay. Question number 8. We've done quite a few like this, so you can probably expect a table like this on your test. We want to figure out Kate's score. Minus 83 divided by 5 is 1.6. Tristan's score, minus 87 divided by 2.5 is negative 2.8. Ryan's score, minus 80 divided by 4 is negative 0.5. And Grace's score, minus 83 divided by 5 is 3.2. Remember to multiply by the denominator and then add the other number to both sides. Go through all that algebra and you end up with Kate being 91, Tristan an 80%, Ryan is 78, and Grace got a 99%. She did amazing. Okay, remember, at any point, if I'm going too fast for you, please just pause the video till you catch up. All right, so for this next one, we're finding the interval that a point is going to fall, and it's given us a bunch of information. I do notice I have the z-score information. So whatever the value is, minus the average, divided by the standard deviation, is going to give me a z-score of 1.5. 3 times 1.5 is 4.5. And then I'm going to add the 74 to both sides, and I'm going to get a value of 78.5. So now I have to figure out where the 78.5 falls. It would be out here, it'd be this one, because this one starts too high. The answer is C. Number 10. If you have a normal distributed data, approximately what percent of the data is going to be with one standard deviation? Remember in the little chart, the first two, the one standard deviations were each 34. So 34 and 34 is 68. Okay, I think I'm going to put number 11 into the calculator again. Remember, you can do this manually, but it's so much easier just to put it in a list. And then you're going to do your stat calculate, one variable statistics. And let's see what that information, what I need. I do know that the average is 83. The standard deviation it's 13.07. I think I'll just use 13. How many grades are within one standard deviation of the mean? So I'm going to think about 83 plus 13 and 83 minus 13. So that would be between 96 and 70. So between 96 and 70 would be 1, 2, 3, 4, 5, 6 numbers. How many grades fall within 2 standard deviations of the mean? Okay, so I'm going to add another 13. And get 109. And actually I'm going to subtract another 13. Remember, when you go down one way, you're subtracting. And that is 57, I believe. So I'm looking to see how many of the grades fall between 57 and 109. They all do. It's 10 of them, all of them. How many grades have a z-score of less than 0.3? So now I need to use a z-score formula. The grade minus the average of 83 divided by the standard deviation of 13 has to have a z-score less than 0.3. Okay, 13 multiplied by 0.3 is 3. So you're going to need to solve x minus 83 is less than 3.9. Add your 83 to both sides and you have x is less than 86.9. So you're looking to see how many grades are less than 86.9, and it's all of these. 1, 2, 3, 4, 5, 6 grades again. One more question. We have a histogram, and we need to shade the intervals that may have data points within 1.5 standard deviations of the mean. Okay, so the mean is 79. One standard deviation is 12. A 0.5 of a standard deviation would be half of the deviation, so 6. It's going to give you 97. Now going the other way, the mean minus 1 standard deviation minus half of a standard deviation is going to give you 61. So I have to shade the intervals that are between 61 and 97. So here starts the 61. And the 97, there could be scores there that are bigger than the 97, but the word may, that it could possibly be there. So these 4 bars of the histogram are shaded in. And this is a real important review. I suggest if you were having trouble with it, print yourself another copy or just start over and try it again if you didn't do well. Also remember, you can text or call me if you have other questions.